you through a fairly fail-safe way to factor anything that can be factored. It will also systematically tell you if it's not possible to factor it. So for any quadratic, in other words, it has an x squared term, and you want to turn it into a product instead of a string of terms added together. And this is useful if you want to graph it, if you want to find out where it is equal to 0, and so basically this allows you to take, if you can turn it into a product, and if it's equal to 0, then you know that either a is 0 or b is 0, and so you can quickly find out what x has to be in an equation like this. Of course, right now this is just the quadratic, not an equation, and so what we're practicing is a bit in isolation, but it's the skill of factoring. So what you want to do, you can also remember this quadratic may look like this, as long as a is not 0. Alright, so you need to have an x squared term. Otherwise, it's actually much more simple if you don't have x squared. It's the x squared that makes it more complicated than just having an equation with x. Alright, but b can be 0, c can be 0. It may not have these other terms, but if it has the square, that is why it's called a quadratic. So in this situation, you would take a and c, keeping the signs with the numbers, take those two coefficients, a times c, as your starting point. And what you're trying to find, of course, when what you're trying to do is you're trying to factor it into two terms. And some people do it by trial and error. Some people have another way of looking at all the different factors of 6 and the factors of 5 and looking for a pairing that will get you plus 7. So this is a much more streamlined way to do it, what I'm about to show you. So take negative 30, and then what you want to do is find two factors of negative 30 that add up to b, in this case 7. The nice thing is most numbers have a limited number of factors, so ignoring the negative for now, you've got 1 and 30, 2 and 15, 3 and 10, and by the time you see 3 and 10 you already have an idea of how you could, or what numbers you might use to get to positive 7. After 5 and 6, this is pretty much all the factors there are of 30, right? 4 pairs, and so that usually is pretty quick to find those. Now 3 and 10 should be able to get us to 7, knowing that one of them has to be negative. So positive 10 and negative 3 looks like our pair here, so they add up to 7. So we're going to use that. So what we're going to do, we're going to rewrite ax squared, we're going to rewrite 6x squared, and then I'm going to split up the 7x into minus 3x and plus 10x. Minus 3x plus 10x. I'll show you in a moment that it doesn't actually matter what order you do that in. Okay, so this, my plus 7x, I've basically split into these two. In order to put this into two pairs, so now I'm going to look at the first pair, 6x squared minus 3x, and I'm going to factor out the greatest common factor, which is 3, and x. And over here I'm left with 2x, and over here I'm left with 1. And then I'm basically looking for this same term to be left over here. And if it helps, you can write it out first, or you can just look at this. I mean, you're going to do the same thing here, which is to take out a common factor. In this case, it's just 5. writing out this can help you with the sign, which in this case is plus 5, right, because that'll give you 10x and that'll give you minus 5. And then we take out 2x minus 1 from both of these terms. Alright, so 3x plus 5 times 2x minus 1. So here's 2x minus 1 times 3x, and 2x minus 1 times 5. And if you want to check, you can multiply these out and ensure that you end up with this. So there's always a way to check. You can always check and see if your answer is correct. Simply multiply it back out, which we'll do here. 3x times 2x, 6x squared, plus 10x, minus 3x, minus 5. And that is indeed what we have here. So what would happen if you did this the other way? Does it matter what order you do it in? This also gives us another chance to walk through the exact same steps. Let's find the greatest common factor in here, which is 2x, and I'm left with 3x plus 5. And over here, really it's minus 1 is my common factor. Or, if you remember, well, we're going to end up with the same thing. Why that happens is basically we force that to happen by doing this, by taking those, multiplying them, finding factors that add up to the middle, and then splitting the middle term into these two terms. We're basically forcing this to happen, or this to happen. So, minus 1. Okay, so again, I can factor out the 3x plus 5 times 2x times minus 1, and you see it's exactly the same as what we had here. Commutative property of multiplication says it doesn't matter what order it's in, a times b or b times a, both of those are the same. Alright, so that is factoring by grouping.